Welcome to our latest video on addition polymers. This video is suitable for GCSE students. By the end of this video lesson, you should understand that alkenes are used to make polymers in a process called addition polymerisation. You should be able to describe the structure, properties and uses of polyethene, polypropene, polyvinyl chloride and polytetrafluoroethene. And you should be able to explain the difference between the term thermoplastic and thermosetting plastic. In our previous video lessons on hydrocarbons, we've learned that alkenes contain a carbon-carbon double bond, and they have the general formula CnH2n. Now this means that however many carbons you have double the number of hydrogens. Now the simplest alkene is ethene, and its molecular formula is C2H4. Now this slide also shows its structural formula, and you can see clearly that it has a carbon-carbon double bond and 4 single covalent bonds to hydrogens. Now because alkenes are unsaturated and have a carbon-carbon double bond, they are very reactive compounds, and because of this they have lots of uses in the chemical industry and can be used to make a range of products including alcohols and plastics. Now plastics are made from crude oil, and plastics are made by joining small molecules together to form long-chained molecules, and any long-chained molecule is called a polymer. Now the plastic polyethene, commonly known as polythene, is made by joining thousands of small ethene molecules together, and the small molecules are joined together to make a polymer are called monomers. Now when ethene joins together with other ethene molecules to make a long-chained polymer, the type of reaction is called addition polymerisation. Polymerisation is making a polymer, and an addition reaction takes place when lots of ethene molecules join together. So this slide summarizes what we mean by monomer and polymer. So if we join lots of ethene molecules together, we make a long-chained molecule. That is called a polymer. And each ethene molecule is called a monomer. Now mer means unit. Poly means many. So many units, polymer. Mono means one. So that's why one ethene molecule that can be joined with other ethene molecules to form a polymer is called a monomer. Now when naming a polymer, you put the word poly and then in brackets you put the name of the monomer. So polyethene is made by joining lots of ethene molecules together. So that's why the polymer is called poly and in brackets ethene. So now let's use our molecular models to explain how alkene molecules can join together to form a polymer. So I'm going to start with just 3 ethene molecules, and I've made models to represent them, and I've drawn their structural formulae. Now remember, when alkenes react, the double bonds break. So I'm going to break the double bonds of my 3 ethene molecules. Now if I break the double bond on each molecule, I generate a spare bond that can be used to join the molecules together. So I'm then able to join the 3 molecules together to form a longer chain. Now this longer chain contains all single bonds and is therefore saturated. Now I'm now going to draw out, using structural formula, what this hydrocarbon chain looks like. And to do this, I'm going to take my 3 alkene molecules and I'm just going to break the double bond, and I generate my spare bond, and the spare bond is used to join the molecules together. Now when I had 3 alkene molecules, I generated this saturated chain of 6 carbons and 12 hydrogens. Now you can see clearly that this unit is just simply repeated 3 times. And this unit is C2H4. Now this is called a repeating unit. Now the reason the repeating unit was repeated 3 times in my finished structure was because I had 3 alkene molecules joining together. Now if I'd had 1,000 ethene molecules joining together, that repeating unit would be repeated 1,000 times. Now it's typical for polymers to have hundreds of thousands of alkene molecules joining together. So therefore we have to have a way of representing polymer formation. And this equation represents how polyethene is formed. So if I have N ethene molecules, so I put N in front of the structural formula of ethene, I would have this repeating unit repeated N times. Now the size or value of N tells you how long the polymer is. So if, for example, N was 1,000, that means that C2H4 is repeated 1,000 times. However, if N is 1,000,000, it's a much longer polymer because C2H4 is repeated 1,000,000 times. Now the repeating unit is C2H4 and N tells you the degree of polymerization. It tells you how many times that repeating unit is repeated. It tells you how long the polymer chain is. As I've said previously in this video, polymer chains can be incredibly long, and sometimes repeating units are repeated hundreds of thousands of times. Now this process, where lots of alkene molecules join together to form a long saturated hydrocarbon chain, is called addition polymerization. And addition polymerization, just like addition reactions, work by the double bond being broken. And in addition polymerization, the double bond breaks and the spare bond that is generated is used to join the different molecules together. Now polyethene is used to make lots of different products. For example, it's used to make carrier bags, it's used to make washing up bowls, it's used to make plastic buckets, it's used to make food wrap, and it's used to make drinks bottles. And the reason it has these uses is because it's strong, it's light, it's waterproof, it's flexible, it's cheap to make. These are just some of the reasons why polyethene has these uses. However, it does have disadvantages and major disadvantages. For example, polyethene, like most plastics, is not biodegradable. This means it doesn't rot away. And therefore, if you put it in a landfill site and try to dispose of it, you would find it would still be there in 100 and 1,000 years' time. And that means that when we try to dispose of polyethene, it is filling up landfill sites because it's not rotting away. Now these plastics are difficult to dispose of, not just because they're not biodegradable, but because when you try to burn them, they give off toxic fumes. So therefore it's very, very important that we recycle plastic, because one, we are saving the environment because we're not filling up our landfill sites, and two, we are saving energy because it takes less energy to recycle plastics than it does to make plastics from scratch. And three, we are reducing our crude oil consumption, and crude oil is a non-renewable resource that is going to run out. Now our second addition polymer that we need to learn for the exam is polypropene. Now polypropene is a polymer that's made by joining propene molecules together. Now propene is the second member of the alkene family, and it has a molecular formula C3H6. And if I draw the structural formula, I put a carbon-carbon double bond in, and I have to make sure that in my chain there are 3 carbons. Now I've drawn 2 propene molecules on the board, so I'm going to draw a third one in as well. So I now have 3 propene molecules, and what I'm going to do is I'm going to join them together by breaking the carbon-carbon double bond. Now alkenes undergo addition reactions, and when they react with molecules, the carbon-carbon double bond breaks. So I'm going to break all the double bonds in these 3 molecules. So I'll break the double bond in the first molecule, and I'm going to just draw propene but without the double bond, and I'm going to use the bond that I've broken as a spare bond that links the 2 molecules together. So I break the double bond, and then a bond forms between the 2 alkene molecules. And then I'm going to break the double bond of the second one, and I'm going to then draw a bond between the second propene molecule and the third propene molecule. Now the result of this is I now have a longer hydrocarbon chain that is saturated. In other words, it's got all single covalent bonds. And you'll notice from my diagram that this unit that I've drawn a little box round is repeated 3 times. And that's because there are 3 alkene molecules that I've joined together. Now this unit that repeats 3 times is called the repeating unit. And if I'm trying to represent the formation of propene with a diagram or an equation, rather than drawing them all out, it's much easier to represent the formation of the polymer using an equation like this. So I'm going to draw my propene molecule, and I'm going to say that if I have n number of alkene molecules, n number of propene molecules, my repeating unit will look a little bit like this. So I just break the double bond, put a single bond where the double bond used to be, and I draw bonds to show that this goes on, and I put a little n by the brackets, and this tells us that that repeating unit is repeated n times. Now if I have n propene molecules, the repeating unit is repeated n times. If I had 1,000,000 propene molecules, the repeating unit is repeated 1,000,000 times. Now propene is a monomer, and the polymer is called polypropylene. So this slide has summarized what we've just discussed. When propene molecules join together to form a long saturated hydrocarbon chain called a polymer, we name the polymer by calling it polypropylene, because propene is the monomer. Now propene and ethene are not the only alkene molecules that we can form polymers from. For example, chloroethene, tetrafluoroethene and styrene can also be polymerized to produce plastics. Now at GCSE, it's important that you can list uses for all the addition polymers on the syllabus. So polypropylene is used for things like milk bottle crates, it's used to make rope, and it's used for carpet fibres. Now the next addition polymer that we have to learn for the GCSE exam is polychloroethene, more commonly known as polyvinyl chloride. So I've drawn 3 molecules of chloroethene here. And I've also made models where I've got a double bond on each alkene molecule and 3 hydrogens and a chlorine atom, which is represented by a green atom. And to join them together, I'm going to have to break the double bonds. And when I break the double bond, I then have all single bonds, and I can use the spare bond that I generate to link the alkene molecules together. Now the result of this is that I have a longer saturated hydrocarbon chain. Now saturated means that it contains all single bonds. Now to represent this, I'm going to look at my 3 molecules that I've drawn structural formula for, and I'm going to rub out the double bonds because I've broken the double bonds where I've joined them together, and I'm going to add in a bond between each of the molecules. And that's what happens when you join the propene and the ethene and the chloroethene molecules together that we've studied so far. Now you'll notice that this unit repeats 3 times in my chain, and this is because I joined 3 alkene molecules together. This is the repeating unit, and rather than drawing all this out, if I want to write an equation to describe what's happening, I can just simplify this by writing the following equation. So N chloroethene molecules produce the polymer that has a repeating unit CH2, CHCl, all joined by single bonds, and this repeating unit is repeated N times. Now the polymer is called polychloroethene. However, this polymer has another name. The old name for chloroethene is vinyl chloride, and the polymer is often called polyvinyl chloride, PVC. Now, polyvinyl chloride, polychloroethene, is formed by joining lots and lots of chloroethene molecules together. And this polymer has lots of uses. For example, it's used for insulating tape, it's used to make Wellington boots, it's used to make window frames, it's used to make pipes, it's used to make guttering, and it's used to make clothing. Now the last addition polymer that we have to learn for the exam is called polytetrafluoroethene. Now this is made from joining lots of tetrafluoroethene molecules together. Now tetra means 4. So if you have an alkene with 4 fluorines on instead of 4 hydrogens, when it joins together, it will have a repeating unit that has all single bonds, a carbon-carbon single bond, and 4 CF single bonds. So my repeating unit looks like this. And the name of the polymer is called polytetrafluoroethene. Now this is commonly known as PTFE. Poly, P, tetra, T, fluoro, F, and ethene, E, PTFE. So this slide summarizes the formation of PTFE, and PTFE is used for frying pans because it's non-stick, it's non-adhesive, and it's also used as an electrical insulator because PTFE, like most plastics, doesn't conduct electricity. Now, PTFE is also chemical resistant, it's heat resistant, and it's also got a high melting point, and therefore it's perfect for these uses. Now for the GCSE exam, you're expected to know the structure, properties and uses of these addition polymers. So polyethene is made by joining ethene molecules together, and it's used for things like plastic bottles, carrier bags, washing up bowls. It's an insulator, so it's used with electrical wiring. It's also used for plastic buckets, and its properties are it's strong, it's waterproof, it's light, it's flexible, it's cheap, it's an insulator. Those are the reasons it has these uses. Now polypropylene is used for rope, it's used to make milk bottle crates, it's used to make carpets, and it's a very tough, hard, strong substance that can be moulded. Polychloroethene or polyvinyl chloride, PVC, is made from joining chloroethene or vinyl chloride molecules together, and it's waterproof, it's flexible, it's a good insulator, it doesn't rust, it's light. These are all properties of PVC, and therefore is used for window frames, drain pipes, guttering, Wellington boots, electrical insulation. Now finally, PTFE is made by joining tetrafluoroethene molecules together, and is used for non-stick frying pans, waterproof clothing and electrical insulation. And its properties are that it's slippery, it's non-adhesive, it's not flammable, which you wouldn't want it to be flammable if you used it for a frying pan. It's chemical resistant, you wouldn't want the frying pan to start wearing away using cooking oil. It's heat resistant, it's an electrical insulator, it's got a high melting point. These are all properties that make it suitable for these uses. Now sometimes a chemical is added to a plastic to make it more flexible. So for example, PVC can have a chemical added to it called a plasticizer, and that makes it more flexible. So if you want to make Wellington boots, you want your PVC to be flexible, so you add this chemical called a plasticizer to make the Wellington boots, because you want PVC in a flexible form. However, if I want to make window frames, I don't want it flexible, I want it to be rigid, so therefore I don't have the plasticizer. So that form of PVC is called unplasticized PVC. And if you see advertisements for window frames, you will see it described as UPVC, unplasticized PVC. Now the last thing we need to discuss in this video is the difference between thermoplastics and thermosetting plastics. Now thermoplastics, sometimes called thermosoftening plastics, are plastics that when you heat them up become soft and runny. And on cooling, these plastics harden, so therefore they can be moulded into shapes after they've been made. Now the majority of polymers that we come across are thermoplastic. So for example, PVC, polyethene, polypropylene, they're all thermoplastics, because when you heat up the thermoplastic, the forces between the chains break easily. The chains slide over each other and the plastic melts. It becomes soft and runny. Now the other type of plastic that you need to be aware of is thermosetting plastics. Now thermosetting plastics do not become soft and runny when you heat them up. The shape is maintained. It stays hard even when you heat it. It doesn't become soft and runny. It doesn't melt. And this is because the forces holding the chains together are a lot stronger. Now this is because there are cross links holding the chains together. And the chains therefore cannot be pulled apart, and the plastic remains solid even on heating. Now you should also be able to name some examples of thermosetting plastics and some of their uses. So some examples are melamine, which is used in worktop surfaces and is used to make cooking utensils. Bakelite, which is used in electrical insulators. and polyurethanes, which is used in mattresses, cushions, insulation, ski boots, toys, etc. Now this is what melamine looks like, and you may come across this in science labs, in workshops, and sometimes in kitchens, and it's used for worktop surfaces. Now, because it's a thermosetting plastic, it doesn't become soft and runny when it gets hot. And this is particularly useful for worktop surfaces because if we put a hot object on it, we don't want the worktop to melt and become soft and runny. We need a plastic that will withstand a high temperature from a hot object. Now, Bakelite is a thermosetting plastic that's used for electrical insulation. And thermosetting plastics are suitable for this purpose because if a plastic is used to insulate an electrical appliance, it's going to get very hot. So we do not want the plastic to melt. Now you may have come across Bakelite before if you've watched old movies because they used to make telephones out of this plastic. Now a third example of a thermosetting plastic is polyurethanes, and these are used in cushions, they're used in ski boots, and they're used as the foam in many car seats. So now we're going to test your understanding of the topics we've discussed in this video with some practice questions. So here's our first question. Now this is divided up into three parts, A, B and C, and this slide contains parts A and B. So read through the question, pause the video, have a go at the question, and then we'll show you part C. So here's part C. Once again, read through the question, pause the video, have a go at it, and then we'll go through the answers to parts A, B, and C. So now let's see how you got on with question 1A and 1B. So for part 1A, the question is asking you to describe what happens to ethene molecules in the production of polythene or polyethene. Well, if you said that the double bonds break, you get 1 mark. And if you said that the molecules join together to form long chains or polymer chains, that gets you the 2nd mark. And then for part B, you're asked to give 1 disadvantage of the use of plastics, such as polythene. If you said that they're non-biodegradable, they don't rot away, or you said that there's increased use of landfills because they don't rot away, in other words, or you said that there's depletion of raw materials, such as oil, because oil is used to make plastics, or you said that when you burn them, they give off toxic fumes, any of those answers will give you a mark. So now let's go for the answers to part C. Name the process taking place when polythene is produced from ethene. Now the process is called addition polymerisation, and that's the best answer you could put down. However, the examiner also accepted just polymerisation. Now it says give 1 use of polythene. So there are lots of possible answers here. You could say carrier bags, household containers such as buckets and washing up bowls, electrical insulation, drinks bottles, etc. And then for part 3, it says give 1 reason why recycling a plastic such as polythene is important for the environment. Now if you said that they don't decompose, they're not biodegradable, and therefore there's less need for landfill sites if you recycle, that would get you the mark. Now I might also accept here if you said it saves energy, because recycling plastics uses less energy than it takes to make plastics from scratch. And if you're generating this energy from, say, burning fossil fuels, you're obviously going to cut down on fossil fuel use if you recycle rather than make the plastics from scratch. And that's going to be better for the environment because you're going to have less global warming. So here's question 2. And question 2 is in 2 parts. And here's the first part. Read through the question, pause the video, have a go at it, and then we'll look at part B. So here's part B, and the question is asking you to give one similarity and one difference between thermoplastics and thermosetting plastics in terms of their structures. So read through the question, pause the video, have a go at it, and then we'll go through the answers to question 2. So here's the answers to question 2. So the name of the polymer is polytetrafluoroethene, PTFE. Don't put Teflon down for this answer because Teflon's a brand name. And part 2 is asking you to complete the equation. So you need the repeating unit correct, and you need a little N because there was N propene molecules. And notice that the bonds come out of the brackets. You need that as well. So there's 1 mark for that. And the name of this type of polymerization for 1 mark is addition polymerization. So for question 2b, you're asked to give one similarity and one difference between the structures of thermoplastics and thermosets or thermosetting plastics. So the similarity is they both have long chains of carbon atoms, they're long chains, or they have large molecules, 1 mark for that. And the difference in terms of their structures is that thermosetting plastics or thermosets have cross links between their chains, or you could say that thermosets have strong bonds between their chains. So there's 1 mark for that. So here's our final practice question. So read through the question, pause the video, have a go at it, and then we'll go for the answers. So here's the answers to question 3. So you have to complete the equation for part 1. So if you draw the repeating unit correctly, so in other words you break the carbon-carbon double bond, so it has a CH2 and a CHCl, and there's single bonds between all the atoms, and bonds come outside the brackets, and you need to include a little N because it's N-chloroethene molecules. That gets you 1 mark. Now for part 2, you're asked to describe the effect of heat on thermoplastics and explain in terms of their structures why they behave in this way. So if you said that when heated thermoplastics melt or they soften, you get a mark for that. And if you said that's because there's no bonds or cross links between their chains, or you said there's weak forces between their chains, that gets you a mark. And for the final mark, you had to say that the chains are able to slide over each other. So there's 3 marks in total for that part of the question. So that concludes our video lesson. So after watching this video, you should now understand that alkenes are used to make polymers in a process called addition polymerization. You should be able to describe the structure, properties and uses of polyethene, polypropene, polyvinylchloride and polytetrafluoroethene. And finally, you should be able to explain the difference between the term thermoplastic and thermosetting plastic. So that concludes our video. Please check out our YouTube channel, Dr. Rowe Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.